Okay, I think I'm set here. So, um, welcome to Code Marathon or Lead Code Marathon session 4. So, in this session, I would want to cover mainly these five problems that I have listed down here. So, I'm looking into like a variety of problems today. Let me open. Yeah, learning a lot since I started this Code Marathon in the beginning, but at the same time, it's not going at at the pace that I was expecting it to. So let's push it a little more and try to solve these problems. If I'm done with these, maybe I can add on few easier problems at the end. If I'm done with these problems fast, I'll add on a couple of easier problems at the end of the session. Otherwise, I'm happy if we can cover these five problems tonight. So let's get on without delaying it. Thank you, Saddam, for your feedback. So I was able to correct my audio because you gave the feedback at the right time. So yeah, let's move on to the first problem now. Let me know if you have any questions, and thank you for joining now. Okay, we had sorted based on the frequency. That's what we will continue. And but I had already selected the problem from where I need to start. I selected few in between. So coin change. So coin change is the first problem that I need to solve. So yeah, lead code number 322, coin change. It's a lead code medium problem. You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. So in this problem, what they are asking is they have given a set of denominations and then they have given a total amount. We need to come up with this amount by using minimum number of this denominations. So for example, if we want to make up for $11, we can by using these denominations we can use two $5 bills and one $1 bill. That would make up $11. So that would make three total coins. In the same way, for $3, in order to make up an amount of $3, just by using $2 bills, it's impossible to uh, give that change of exactly $3. And for making up an amount of $0, we just need zero denominations. We don't need anything. So that's the scenario. So how to come up with the solutions for this? So as and when I think about this, the thing that strikes me in my mind is backtracking. So why backtracking? First thing is, if they have given a total amount of $11, how can I make up for $11? First thing I'll think is, okay, out of these denominations, if I take a $5 bill, then then the problem remaining during backtracking is like how to make up 11 minus $5. So it will be the solution will be 1 plus 11 minus $5. That is 1 plus how to make the same come up with the coin change for $6. Or else if I use some other denomination like $2 bill, so 1 plus coin change of $9. How to get that? So whichever gives me the minimum value, so I can just return that as a output. Let's see how I'm thinking here. Let's represent the same thing in the code. So here, first thing is, okay, min coins required. Okay, minimum coins required, that would be an integer, and then let's instantiate it to integer dot max value, that is the worst case value. And then let's loop through this array for coins, for int coin, or loop through these denominations. And let's see one thing, like, okay, I'm using all three coins. Let's say if I use $5, then what would be the result? If I don't use 5, if I use $2, then what would be the result? If I use $1, what would be the result? So before that, I need to understand the base case. If amount is equal to 0, then I think I can just return it as 0. I don't have to do anything. And here, or another thing is, what if it goes negative? If amount is equal to, or amount is less than 0, then I think I can just return integer dot max value. I mean, that means it is impossible to get to that denomination. So I'm taking the coins considering the coins one by one. Now I need to check if if coin change of, okay, coin change of using this coin, or using these coins, and amount would reduce to amount plus 1, sorry, amount minus coin value, or this denomination value, is not equal to integer dot max value, then I think I can consider that's a valid result, right? Like if it doesn't return it as integer dot max value, that means that would be one of the valid results. Then I can compare it with min value until now. Min value is equal to math dot minimum of min coins required and whatever it returns. So rather than recomputing this, let's do this one. Okay, here integer um, coins required is equal to coins required with using, okay, current coins required, let's say. Okay, current coins required means if I use this coin or one of the denominations, what's the total number of coins required? Then what I'm doing is coin change of, I'm calling with the same coins denominations. I'll have all the denominations, but amount will be reduced to, if I already use this current coin, amount will be equal to amount minus coin. And then if that returns a valid output, if that returns a valid output meant to say current coins required, it is, if it is not equal to integer dot max value, then I think I'll compare it with the min coins required, which I had initialized to max value, and then I will add it to the min coins required. Okay, and in the same way, I'll keep looking for the for the combination of each of the denominations. First time I'll try with $5. If I use $5 denomination, then how it will go. Next thing is, in this example, first thing is I'll check with $1 denomination. If I use $1 denomination, and I'll call the coin change for amount of $10, because amount of 11 minus 1 10, and I'll use $2 denomination, then amount would become 9 here. I'll call the coin change with $9 as amount, and I'll use the $5, then I'll call the same function with amount is equal to $6. And then whatever is returned from all these three methods, if that is a valid output, I mean, if I can make a change out of using all those denominations, then I'm comparing what's the minimum coins required, and then I need to output that uh, value. So let's see, if minimum coins required is equal to, is not equal to, or let's say if that is equal to integer dot max value, that means, okay, there was no valid output using any of the denomination. then I need to return -1 as they have mentioned in the question here. Return the fewest number of coins that you need to make up for the amount. If that amount of money cannot be made by any combination of coins, then return -1. So I'm just returning -1 if it is not a valid combination. Otherwise, I'll return this min coin required. So now another catch is here I am checking only if it is not equal to integer.max value. And all I need to check if like let's say I called the function, this coin change function here for $6 as well. And I called it for $9 and $10 also. If those functions returned it as -1, then I would have considered this one because I'm checking only for if it is not equal to integer.max value. I need to consider now as current coins required is not equal to -1 also. Then I'll consider this. Maybe I don't need to do this one because if it is invalid anyway, I'm returning -1. So yeah, I can remove this and check. Okay, and here also I can remove if it is less than 0. I can just return -1 as it is directly. Yeah, so this looks good to me. So let's run this and see for the base cases. Okay, it is giving time limit exceeded. So yeah, for backtracking, I was expecting the time limit exceeded, but I was not expecting for this problem. I mean, um, for this input itself, the time limit will exceed. So amount is given as 100 here. Amount, let's say, let's let's check that for amount 11. Okay, amount 100. Where is it? Okay, let's remove this. Okay, let's check for these base cases without amount 100. Okay, for amount 11, now it is giving a wrong result rather than time limit exceeded. It is given output as 0. Why it is given it? Why it is returning it as 0? So let's see. Okay, yes, it is. It will give it as 0. It will return it as 0 because we have made a like basic mistake here. So the total coins required for this one is equal to current coins required will be is equal to whatever this function returns plus 1. So current coins required is equal to okay. So if I didn't add +1 here because it might have been returning -1 already. So if I do -1 +1, it will become 0. So what I can do is current coins required +1 here. Okay. If current coins required is not equal to -1, I'm checking the min coins required will be is equal to current coin required +1. Okay. So now we can see all of these uh, all of these inputs works. For 1 to 5, I know that to make up $11, we need 3 denominations or 3 coins. For making up $2, for making up amount of 3 using 2 denomination coin, it's not possible. The same way, uh, yeah, to make up an amount of 0, we just need 0 coins. To make up an amount of 9, we need 3 coins with the combination of these denominations. It didn't give output as 5 1 1 like 5 and 4 ones. That could have been an obvious choice if we considered 5, or 5 3 1 also could be that take up only 3 denominations. But yeah, all these are right answers here. Here we can see to make up 27 we need 2 10s and 1 5 and 1 2, so that makes up 4 denominations. So that's the optimal one. So it's returning the right answers for all this. But let's see, for this one only, for the same test case, let's make it as 110 dollar. So now it will fail. It will give the time limit exceeded. And that was expected. We are just using basic backtracking, and we are not like we are not optimizing this approach optimize this approach anyway. So yesterday we looked into few of the dynamic programming problems. So in dynamic programming, how can we think how shall we think about dynamic programming? Let's say here, let's go back to this whiteboard. Here, let's remember these denominations. So okay, okay, we have this coin change problem. Let me take an example here. Okay, the basic, okay, basic optimization I'm looking for is, or basic inefficiency I'm seeing here is, to find the dollar 110. First thing is, this will invoke in order to figure out for 110. I'm iterating through each of the denominations. It will make a call to $109 as an amount, and then it will make a call to 110 minus 2, so that is 108 as dollar amount, and then again it will make a call to min coins required for 110 minus 5, so 105 as the amount. So this so 110 will make these three calls, and then again for each of these, let's say for each of these, so we have 109 and 108 and 105. So here for 109, again it will call to 109 minus 1, 108, 108. So this, let's say this as level 2. Okay, so I'll add a separation here. 108 and 109 minus 2, so that would be 107, and 109 minus 5, so 104. So these three. So we already saw one repeating. So 108 should be called again, and I'm calling 108 here. So 108 minus 1, 107, and 108 minus 2, 106, and 108 minus 5, that would be 103. Let's see for 105. For 105, 105 minus 1, 104, and 104, 105 minus 2, 103, 103 minus 105 minus 5, 100. So we can see we are calling the same function here with the amount 109, 108, and 105. Again, internally, in order to figure out the min coins for 109, I'm calling 108, 107, and 104. So the same to figure out the amount for 108, it's calling 107, 106, 103. We can see so many repetitions here. 108 once, 108 here, and 107 here, 107 here again, 104, 104, 103, and 103. By the time we try to get the value down to 0, there will be uh, exponential amount of repetitions here, repeated computations. So that's why the time limit is exceeded. When the amount was 10, yes, there were also repetitions, but it was like, okay, it was manageable within that time, even though there were repetitions. So when the amount gets larger, the repetitions would become more. So how can we optimize it? We can optimize by, like, okay, we called for 109 here. What's the minimum coins required for 109? Once we get to know that, let's add it in a memo of uh, memo can be an array, or it can be a hash map. Memo of 109 should give us a minimum coins required for 109, and memo of 108 should give us the minimum coins required for 108 amount. So once I compute it for 109, I don't have to recompute it again. Once I compute it for 108, again it's calling 108. I should be just be able to look up the memo and return the value rather than trying to compute 108 again and coming up with all these optimal substructures or repeated substructure or repeated subproblems. So I hope everybody I hope I made sense why it is taking so much time to compute this or recompute these subproblems. Let's go back to the code and do that optimization to store the already computed values. So let's see how to add the memoization. So let's just take a basic. So here two ways we can add memoization. One is either we can use a array list, primitive array list, and add like for, for like array list of size amount. Amount is let's say 110, then we will be adding 110 different boxes, and for each of those we will add the minimum coins required for that particular amount. Otherwise we can do a hash map. So I prefer hash map in this case specifically because I don't know if I need to compute the coin change for each of the amount that is less than the given amount in the main problem, less than 110 in this case. So I'm not sure like if the coin change or the coins were like of the denomination like 25 or 35, then I don't think we would have needed to recompute a lot of things or store a lot of things there. We might have recomputed for 25 only again and again. So rather than having to have it in an array list with 110 different spaces, let's have a hash map as memo. So that will store the amount. So amount to total min coins required in that memo. So I'm initializing it to it as a hash map. We can do that here since we do not have to. Okay, if I'll be using this as we are using this as recursive function. I don't want to initialize it again and again. So let's create a constructor and initialize within that public solution. Okay, so now memo is equal to new hash map. So now we have a memo. What should we do next? Next thing is okay, for 0 return 0. I don't need any optimizations for that. For negative also I don't need any optimizations. And after this one, let's see, in order to avoid the recomputation, if memo dot contains key of amount, whatever the amount is given, then I can just return memo dot get amount, and I don't have to perform any of this again and again if I already have that in the memo stored. If that is not stored in the memo, then I computed the min coins required and did all these things, and here I need another step to add it to the memo. So memo dot put amount. For the amount, what's the min coins required? So I think I can add the same logic here. Okay, min coins required is equal to integer dot max value. Then I'll return it as -1. Otherwise, I'll return the min coin required. I'm adding that to the memo also. So here I can just do memo dot get amount. Again, let's run this one and see have we made any if we have made any improvements. Okay, we can see here now the amount is 110. For 110 also it's getting executed quickly without taking much time. And let's try to scale up the other test cases as well. So instead of 90, make it as 900. Okay, so for 900 also it executed without much problems. So that's how we can convert this backtracking approach to a dynamic programming solution using memoization. So we just save the intermittent or intermediate results in this memo, and then we were able to uh, improve the improve the performance just by querying for that from the memo rather than recomputing it. So that's about this problem. And time complexity wise, we are computing we are computing for all the amounts. Like in the worst case, like all the amounts means if the amount is 110, then we are computing for all the values lesser than 110, and then we are checking the combination by using these three denominations. So the time complexity is directly proportional to amount cross number of denominations. So if the number of denominations is n, and if the amount is, let's say let's say s, so then it will be s cross n. If the amount increases, then the complexity or the runtime increases proportionately, and if the number of denominations or the choices that we have is more, then also the runtime increases proportionately. So that would be the runtime complexity. Another approach for solving this one is without using recursion, we can solve it by using bottom up approach. So let's say in the bottom up approach, we can just build up from um, how to how to get to the amount of $3. What's the minimum coins required? How to get to the amount of $4? What's the minimum coins required? Like that, we keep building up to the value amount, if that's possible. If that's not possible, we will return it as -1. So without recursion, we can do that as bottom up. So that should be it for this problem. Let me know if you have any questions, or feel free to post a comment once you watch this one. Let's move on to the next problem now. Okay. So the next problem in the list that we thought was alien dictionary. Did we run this amount or submit this amount? Let's submit it and see if there are any other use cases. Okay, it succeeded when we submitted also. Let's go back and let's solve the alien dictionary. Okay, so LeetCode 269 alien dictionary. This is a LeetCode hard problem. It is actually a little tricky and little, even if we know the solution, if we looked into the graph again and again, in order to come up with this problem, we need our mind to be sorted and clear at that moment. Otherwise it is tough to code up this approach. So here, let's read the question. There is a new alien language that uses English alphabet. However, the order of the letters is unknown to you. You are given the list of strings words from the alien language dictionary. Now it is claimed that the string in words are sorted lexicographically by the rules of this new language. If this claim is incorrect and the given arrangement of strings in words cannot correspond to any order of letters, return just an empty string. Otherwise, return a string of unique letters in the new alien language sorted in lexicographically increasing order by the new language rules. If there are multiple solutions, return any of them. Okay, that sounds good. So okay, here they have given, okay, there is another alien language which is which uses the English alphabets but not in the same order. Like instead of A there can be W, or instead of B there can be X, in that order. Like the order is different and order is not given to us. But they have given a list of words which is sorted in the lexicographical order. So which is sorted lexicographically. When they mention sorted lexicographically, that means a string A is lexicographically smaller than a string B if the first position where A and B differ. String A has a letter that appears earlier in the alien language than the corresponding letter in B. Okay. If the first min of A length or B length characters do not differ, then the shorter string is the lexicographically smaller one. Okay, shorter is the smaller one. So here they have given the lexicographically sorted words or sorted strings, and we need to, and that is sure. So based on the relationship we can determine from here, we need to be able to provide the output in this format. In the output is sorted. So we need to provide the sorted output in that alien language. Okay, that's a bit challenging. So let's see how we can get think about this one. So for now, like let's forget about coding. If we just read this problem, or if we are looking into this input words, let's see, these two words are given and we can determine the relationship between these two, right? Now WRT is smaller than WRF based if the input is valid. So that, and in WRT, WW is same, RR is same, T is less than F. So that is for sure the relationship based on these two words, because this comes before this means this is the smaller word, this is larger. So T comes before F. So that is the relationship that we can establish. And in the output also you can see T comes before F. And here bef- within these two words, the relationship wise, we can see first letter itself is different. So W and E. So W comes before E. So W is smaller than E. So we can see here W comes before E. W is smaller than E. I mean, it doesn't have to be continuous like this, but W is before E. That's all. That's the relationship that we can deduce from this order. Let's look into these two words, ER and ETT. EE is similar, so we can't think of much. R and T. R comes before T, so R is before T based on the relationship in these two words. And ETT and RFTT. So here E first letter itself is different. E is before R, so E is before R. So with that, with all that information available, we need to be able to come up with the lexicographical order for this alien alphabets, or alien arrangement of English alphabets. So yeah, so that is the problem. First thing is, okay, we know that, okay, we have the words and they have certain relationships. So we with that, let's determine the relationship between the characters that we can think of. As we just saw with our plain sight, we should represent that in the graph as well, like a dependency graph. Like, okay, this should come before this one, or this is of less value than the other character. How to represent it? Let's represent it as an adjacency list. So I can have a character and a set of characters which which has the relationship. Okay, so now this character is less than all these means I think I can just have that mention, like, okay, now if I know that, okay, W is less than RT, I can just capture that in this adjacency list by having W and a set of all the characters that uh, that that would be coming after this one in any arrangement. Okay, so here this one I think I can just call it as graph because I'm representing the nodes here, and hash map. And okay, and here another thing is I need to go through each of the characters in those words and then add it to the graph first. So just to get all those characters, later on we can think about arranging it or representing the relationship. So let's take all those characters first. String word in words array, and then if, and then also for every in within every word, let's take the characters to char array. Okay, so now graph dot put if absent current comma new hash set. Okay, I have initialized the hash set in front of each of the characters in all among all the words there. And another thing is, okay, now we need to represent that relationship that we thought of, like that we looked into using this word by word comparison. So let's look into how to do that. For int I is equal to 0, I less than words dot length minus 1. Why less than words dot length minus 1? Because I don't want I to go here, because I'm comparing I and I plus 1th word. So now I is 0, I'll compare 0th and first word. And then when I is 1, I'll compare first and second word, like that. So yeah, you will know as and I go forward. Okay, I plus plus. So usually we represent less than just word dot length. Now I'm represented word less than word dot length minus 1, because I'm taking combination of two words every time I need to compare. So word 1 is equal to here words dot or words of I. Okay, and word 2 is equal to words of I plus 1. So one thing we need to be sure here, if we think the input is invalid, then we can just return it as a empty string. So when it is invalid, if the if both the like they have been saying, whichever the word has min length, and then if that is the substring of another string, then that is of the smaller value. So let's say if word 1 dot length is greater than word 2 dot length. Okay, word 1 is greater than word 2, and if word 2 or word 1 dot starts with word 2. Okay, what does this mean? If word 1 dot length is greater than word 2 dot length, and if word 1 starts with word 2, that means if word 2 is a substring, or if the starting letters are, it contains the entire part. If word 1 contains the entire part of word 2 and has few additional characters, that means word 1 is supposed to be smaller than word 2. Sorry, one word 1 would be greater than word 2. But here in the arrangement, word 1 is arranged before word 2. So that's why it is invalid. That's why we would return it as an empty string. But yeah, if that is not the case, then what we will do, we will have to see the characters, see, like, check each of the characters one by one. Okay, how do we do that? For int j is equal to 0, j less than math dot min of word 1 dot length, comma word 2 dot length. Okay, and j plus plus. Okay, I'm iterating through each of those characters. Let's say if we take this example, this is word 1. Okay, so WRT is word 1, WRF is word 2. Okay, both are of same character length, but if say one of them was a larger word, or a bigger word, then I'm taking the length of the minimum length word, and I'm iterating till there. And now let's see, let's make it more readable, because the problem itself is a bit difficult. So character of C1, let's say character S or char1 is equal to word 1 dot char h j. Okay, this is the caret j in word 1, and this is a caret j in word 2. Okay, if C1 is not equal to C2. Okay, what I'm trying to come up here is, we are going through each of the characters one by one. Okay, WRT and WRF, we are comparing these two. Okay, we took the character at 0th index in both the words. They are equal, so I don't have to do anything. And here R and R, again, those two are equal. We don't have to do anything because we cannot deduce any relationship with that information. And now T and F, they are not equal, they are different. So when C1 is not equal to C2, then only we have some rationale or some information about the relationship between them. When C1 is not equal to C2, then I think what I can do is uh, I can just add C2 as one of the characters in C1's adjacency list. So graph dot get C1 dot add C2. So in my graph I just added T and F like this basically. Okay, what this one is forming is, okay, I have a hash map like this, and here I have a T1 is T. Okay, T should have a list of characters as values. So first character I added as F into that, and then next thing I'll be comparing word 2 and word 3, word 1 and word 2. So here the first character itself is different. Okay, once I find out, okay, one character is different, I think I can just break out of the loop. Like next character wouldn't give us any information. So this word is less than this because the first difference that occurred in this third character, that's the information we have. So I'm breaking out of this, and I'm comparing WRF with ER. So here first character itself is different. That gives the value W is less than E. So that with that information I can store like this: W is less than E, or E before E I have W. And now I'll compare ER and ETT. E and E are same, no information. R and T, R is less than T. So now I think I can represent R value T here. Okay, and then ETT and RFTT, first letter itself is different. E comes before R, that means E, E is before R. Okay, now I have all these information. This is the graph that is formed with all this information. So now the next step is I need to traverse through that graph and then arrange them in the order in order to come up with the lexicographically increased order. Return a string of the unique letters in the new alien language sorted in the lexicographically increasing order. Okay, so how to traverse this graph now? For graph traversal, as we know, we can use either breadth first search or depth first search. Here, I think I'm better off using depth first search, but no opinions. Basically, like if we consider the runtime, both should be the same. So I'm just using depth first search or depth first traversal as my preference in order to arrange it. Let's say in order to arrange, after arranging, like how we traverse through the path that we take to traverse, that one we can store it in a string called uh, sorry, stack of strings. Okay, once I initiate a string, next what else we need? I need something as a visited node. So like in the DFS, like if we have already visited something, then we need to capture that. So I'll capture it as character comma integer. I'm taking integer, not boolean, because I need three three states here. So one state which signifies that, okay, graph that node is not at all visited, and one state which signifies that I'm currently visiting that node, and another state saying that, okay, I already visited it. So when it is being visiting, when I'm in the visiting state, if the if I come back to that the same node which I'm visiting, that means there is a cycle in that graph, then I can just return a empty string. And also if I'm done visiting a node, then I think I can just add it to the stack, that okay, so that dependency is done, or that node is done, so I can add it to the output. So that's the rationale there. So in integer, I think I can just say 0 as unvisited, 1 as visited, and -1 as visiting. So I mean any three, 0, 1, 2 I can take, or any three values I need. So or else I can just have a enum with all these three values, and I can manage as well. So that is also a good way. So let okay, visited, new hash map. Okay, but before doing this, I want to initialize all the characters as unvisited. So rather than initializing it here, the visited method, let's initialize it in the beginning itself. And when I was adding the graph, or uh, adding the characters into the graph, let's mark it as current and not visited. Not visited means 0. Everything is marked as unvisited. Okay, so now that is done. So I have the visited also. So now what else I need? If DFS of, so I'll run the depth first traversal, and if in the depth first traversal, as I said, if I find a cycle, then I should immediately return an empty string as invalid. So I think I can just return something like a return true or value, true or false values for if I find cycle. So if I find a cycle, then I'll return it as true in DFS. If I don't find a cycle, then I'll return it as a false, and I'll just add it to the stack. Add the stack, the order in which with which I do traversal. So in order to traverse these traverse these nodes, first thing is I need the comprehensive list of nodes as well. So how to get the comprehensive list of nodes? So let me see. So comprehensive list is in both of those characters, visited um, as well as in the graph. But yeah, I think I can use the graph itself for character. Uh, let's take it as a node for now here, and then graph dot key set. Okay. So here, if the node is already visited, if the visited dot node, sorry, visited dot contains, or visited dot get of node is equal to 0. So if it that means if it is unvisited, then I will run a DFS. For DFS, I'll pass the node, and what else do I need? I would need the graph, I would need the visited, and also I would need something to store the output, that is the stack. And if this returns true, if the DFS returns true, that means I said it has a cycle. So that means I'll just return it as invalid. Okay. If not, if the cycle is not detected, then what I'll do, I need to, I can I can take the last one in the stack, and then I'll append it to the output in the reverse order. Let's say I'll just take a string builder result. Okay, and while okay, I'm done with the entire traversal and no cycle is found. This means if it didn't return an empty, if the no cycle was found, then I'm just checking if the stack was not empty, and until the stack is not empty, I'll get all those characters and I'll keep appending that to the result. So if I do that, so basically I'm reversing the direction of the stack, and then I'll return the result by converting it to string format. Okay, so this is like the basic structure of the problem. Like I arranged the input into adjacency list, and then I added the relationships in the adjacency list, and then based on the traversal, I captured the order in which the traversals happen in the stack without cycle. And if there is no cycle, I'm arranging it in the output string as well. Let's say how to implement the traversal now. So in order to implement the traversal, private and it should return a boolean to signify if it encounters a cycle or not. So dfs of, so character node, and then the next thing is graph and then visited. So for the graph, I can just copy the same thing here, and for the visited also I can copy it from its declaration here. Okay, and last one is the stack. I can have the stack also here. Okay, now as soon as I come to traverse, first thing is I'll mark that as visited dot put. I'll mark that node as being like I'm currently visiting. Once I mark that, I need to traverse through each of its neighbors. So for character neighbor graph dot get of the current node. So I'm getting the current node, all the neighbors of the current node, and if the neighbor is already visited, or if the neighbor is currently being visited, and if I encounter that again without completing that visit, then I should just return it as cycle. If not visited, and if it's visited, I should not do anything. Like if it's already visited means it would return a value of, it would have a value of 1. But if it is unvisited, then visited dot get of neighbor is equal to 0. If it's unvisited, then I should do a traversal there. I will traverse that one also in the same way. Like let's say, okay, dfs of, I would traverse neighbor in this case, not the node, neighbor, and then see if there is a cycle in that one. Again, I'll return it as there is a cycle. Otherwise, do nothing. I'll I'll have to add that to the stack later. So if I didn't find any cycle when I'm traversing, that means my visiting is done. So that means I can mark that the current node as visited dot put node as visited. So that's, I'm marking it as visited. I'm adding the same. Once I'm done with the visit of that node, I'm pushing it to the stack. So I'll push that to the stack, the current value of the node, or the value of the current node, and I'm also returning it as there was no cycle. So I'm returning it as false. So this should provide the entire solution for this. Let's run this and check what we have missed. Okay, set of characters, not characters. I think I copied the same thing in the declaration here also. Okay, and there is a typo here also. Character, character. This one is not correct. And I copied that again here in the DFS declaration also. Yeah, character. So now there is no typo. Let's see now at least. Cannot find symbol visited. Okay, so I should do visited dot put. So visited dot put, and then char one, char one not equal to char two. Okay, here this one should be char two, and and char two, char one. Oh, so I think this is super cool. We are able to get the solution except for the certain typos that we had missed. So it is giving the right answer for all the base test cases at the least for now. Oh man, I can't express my happiness with this one. I was able to get this without much um, troubleshooting and in the first run itself. So that is cool. So let me see. ZX. Okay, let's run this for the rest of the test cases also. I mean, just submit it and see if there are any things that we nothing. So this looks good. So I don't want to make it complicated. So I had this comment to explain how we built the adjacency list. That is not needed. That's given now. So yeah, so this looks good to me. So I'll just submit this now again, and please post if you have any questions about this, and let me know if I have to explain it, or if I have to explain breadth first search approach also. I'm okay to explain, but it should be very similar. But yeah, but yeah, I'm glad. I hope the explanation was clear though. I tried to break it down as much as possible, and give the solution. Yeah, let's see. I think Shaker is commenting there. How can you be able to do this hard level problems? I'm not able to do. Okay, Shaker, I think it's mostly there's no shortcut for success, as I believe. So I have this is not the first time I'm looking into this problem or the graph algorithms as well. I first time I graduated in 2015, so I did a lot of not lead coding at that point. I think I did solve a lot of problems with Geeks for Geeks and some other sites and everything. And I looked into the or read cracking the coding interview several times, and I had taken the graph algorithms course as well in as part of my college work. So that was one time, and then I switched the job in 2021 once, and I had done some basic preparation at that point also, and I had switched a job a couple of years later as well. So I had done some basic preparation. This time while preparing, I had looked into the graph algorithms and I have created a set of videos, but I had not coded alien dictionary, but I had done all types of graph traversals and other problems. So that kind of set the basics for this. So with that basics, I was able to build on to add this one. If I had looked into this problem directly, Yeah, keep practicing, keep building up from the easy ones to the hard ones. But yeah, focus on the basics. That's what I would stress on or emphasize on always. Cracking the Coding Interview is the best book, and also you can look into the live streams where I have explained the basic problems and also the basic data structure implementations. Those are very, very important. uh, so I have a set of videos made for graph algorithms and binary trees, binary search trees, and for min heap also. So those data structures I have explained, so that will be very useful. Not just my my content. There are several content available for the basic data structure explanations. So those are very important before we solve any lead code problem. And I am always here to help when you are learning. Let me know if you encounter any questions. Just post it in a comment, and I'll make sure to reply those. Or you can just contact me in my email. As I mentioned, it is my channel name at the rate gmail.com. Yeah, let's move on to the next problem now. So lead code 55 jump came. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. Okay, so again, I think of backtracking or dynamic programming, those kind of solutions for this one. But here, I don't have to accurately jump to the last index. Return true if you can reach the last index, or false otherwise. Here in this case, I can go beyond the last index also. That then also it would satisfy the requirement for me. So in this case, I can come up with the solution with greedy approach as well. So how do I do with greedy approach? So that would solve this problem in O of n. I think if I take dynamic programming, it will be O of n square, I assume. And if I take like a backtracking, then it could be exponential time. So let's look into how the greedy approach works. So with every index here, I know the farthest that it can jump. So we can start with the first index, and we can keep going every index. So from the first index, I know I can jump till the index 3. That's the farthest I can jump. And from the second index, which is here, I can jump till the index, this index. I mean the index 4 or index 5. And if, whenever I reach a particular index, I want to make sure that the farthest jump before this node was at least this node, at least until this node. I mean, when I try to iterate through a node or an index, then I should know at least I was reachable to this index from the indexes before this. So if I know that, then I we can keep going until the last index, or until wherever we can go. And if we are able to reach the last index by following the same logic, that means we can return true. If we are not able to reach the last index, then we can return false in between, wherever the wherever the condition fails. Let's look into that. So for us now, index is important. So let's use the for loop with index, not with the iterator. So I is equal to 0, I less than nums dot length I plus plus. Okay, if, and let's compute the farthest jump here. Farthest jump is equal to, let's initiate the farthest jump here, be outside of this loop, is equal to new. Okay, is equal to 0 for now. Okay, and then farthest jump is equal to math dot max of current farthest jump, and then I plus value at I. I mean, from 0, if the value is 2, 0 plus 2, we can jump till the index 2. That means, so nums of I. that would be the farthest jump. So now here, let's see, if whenever we come to any node, if the farthest jump was less than the current node, or less than the current node means less than the current index, means if it is less than I, then I think we can just return false here. Otherwise we will compute the farthest jump, and then as the math.max of the current farthest jump, or by computing the jump in the current index. Let's see, and then we can return it as true if we are able to iterate through each of those nodes without arriving at this condition. This should work. Let's see. Let's look into the examples here. 23114. So here, farthest jump will be initialized to 0, and then first in the first iteration, or the first value, okay, I is equal to 0. Farthest jump is not less than I. Farthest jump is equal to I. So I won't return false. So this doesn't satisfy. Farthest jump value I will update as I plus nums of I plus nums of I means I is 0, nums of I is 2. So farthest jumps becomes value becomes 2. And then, okay, I come to the next index here. I is equal to 1. So this condition doesn't satisfy. Farthest jump is not less than I. It is greater than I. So farthest jump value is updated to I plus nums of I. I is 1, nums of I is 3. So that becomes 4. That makes it 4. And I come to the next index here, 2, index 2. So index 2, and this condition doesn't satisfy here. Farthest jump also it will remain the same thing, because 2 plus 1 is 3, but our farthest jump value is already 4, so it will remain at 4. And then I'll come back here again. Index will become 3. Again, this condition doesn't hold good. Farthest jump is calculated as 3 plus 1, 4, which is same as whatever we had before. So that remains 4. And then I'll come back here. Index is 4. And then in the fourth index, again, this doesn't satisfy. I'll compute the farthest jump as 8, but which is no more, like, which doesn't matter for now. And then once all the indexes are traversed, I'm returning it as true. So this is the positive case. Let's see for a negative case also. So here 32104. So the first index, from the first index I can jump till third index. From the zeroth index I can jump till third index. 0 plus 3 would be 3. And then from the first index I can jump till third index only, like, because 1 plus 2 is 3, and it will remain the same thing. From the second index, 2 plus 1 is 3, so this will remain the same thing. From the third index, again it will be the 3 plus 0 is equal to 3 only, so nothing. And from the fourth index, I come here, and this condition satisfies if the farthest jump is less than I. Farthest jump is 3, and I is 4 now. So I would return false, and this returns false, that the jump is not possible until the last index. Let's run this one. Okay, farthest jump cannot find symbol. Maybe, okay, there is a typo again. Yeah, okay. Okay, now it works. So let's remove this comment as well. Yeah, let's try to submit this for the other cases as well. Okay, it works. So yeah, so this is the O of n solution. We are looking into each of the element only once and arriving at the solution. So this is kind of a easier. This was kind of on the easier side. This uses the greedy approach. From every node, I'm checking what's the best I can do from this node, and yeah, I'm traversing further after that. That should be it about this problem. Okay, let's see. Let's move on to the next problem. So the next problem that we thought for today was house robber, I assume. Okay. So house robber. Lead code number 198, house robber. And it's a lead code medium problem. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array of nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so this is a hypothetical scenario where the robber knows how much stash is in every house, or how much, how much, yeah, whatever the uh, worth of worth of things are there in each houses, and okay, money stashed in each houses, and based on that, the robber has to devise an algorithms to decide which houses that he would choose in order to rob to make the maximum profit. And the condition given is he cannot rob two neighboring or two adjacent houses, because that would contact the police automatically, and he will be caught. So without alerting the police, he needs to make the maximum profit. So how do we calculate that? And we should, it is the same thing with the entire city. Let's say he need to devise a algorithm in order to, while considering every neighborhood to rob. So let's see. So here we can start, okay, nums is, and the input is given in the form of nums. So this is the house number. Let's say index is the house number, and the value in every index is the money that is stashed in every house. So let's see. Two houses cannot be robbed. Two adjacent houses cannot be robbed on the same night. So if we decide to rob house with index 0, we cannot rob house with index 1. And the same with, if we if the robber robs house with index 1, then he cannot rob the house with index 2. So how to come up with a solution which will yield the maximum value for his robbery? So what we can do is, somehow we need to capture the first house and the second house. So, and then while coming to the third house, what one can do. So while coming to the third house, he should be he should decide to go with either he should decide either to go with the first house's money and third house's money, if we consider as three. Okay, let's take this as a sub problem. If there was only one house, then he will just rob that house. If there are two houses, then he will rob the house with the maximum money, because out of those two neighboring houses. If there are three houses, then what he can do is, like, okay, he can, in the third house, he can either combine the money in the first house and then see what's the amount does he make. Otherwise, he can just be happy with whatever the money is in the second house. And in the fourth house, he will see what's the best result until what was the best result until the second house, like whether the first house was greater or the second house was greater, and then he will decide based on that. Let's see, how to represent it in the code. So if first, let's address the base case. If nums dot length is equal to 0, then just return nums of 0. Okay, nums dot length is equal to 1, then just returns nums of 0. Okay, at least there is one house. So that's the constraint given. So we don't have to check for 0 houses. If nums dot length is equal to 2, then just return math dot max of nums of 0 comma nums of 1. Okay, so after this one, let's see, int previous house, previous, um, let's say previous 2, let's initialize it as nums of 0, and in previous 1, we can initialize it as nums of 1. And then let's start iterating through each of the houses, or each of the yeah, for int I is equal to 2, I less than nums dot length I plus plus. Okay, and int current, now in the current house, when I come to the current house, then the maximum value will become either math dot max of, either include the current one, how to include the current one, that will be nums of I plus previous 2. I mean, not the just the previous one, we cannot consider just the previous 2, or else just walk away with previous 2 money, don't consider the current house, or I mean previous 1 money, don't consider the current house. And then assign current is equal to, or previous 2 is equal to previous 1, previous 2 will become previous 1, I mean previous 1 will become previous 2, and then current will become previous 1. Okay, yeah, current will become previous 1. And then after iterating through all of those, just return the current at the end, at the last house. Let's see, let's run an example in this one. So now in this, with this example, previous 2 will be equal to 1, previous 1 will be equal to 2, and then math dot max of 1 comma 2. So 1 comma, okay, math dot max of 1 plus 3 or 2. I mean max of 1 plus 3 or 2 means, so obviously we'll return it, we'll take it as 4. And then here previous 2 will become previous 1. So previous 2 will become 2, and previous 1 will become current, which is 4. Okay, again, now I is equal to 3. So I'm at the third house here. So I'll consider current is equal to math dot max of nums of I, which is the third house 1, 1 plus previous 2, 1 plus previous 2 is 3, and previous 1 is 4. So yeah, current will remain as 4, and then modify, which is insignificant anyway because we are done with the done with all the iterations, and we are returning current which is 4. Yeah, so let's look at the little more complicated ones. 27931. Okay, in this one, previous is previous 2 is 2, and previous 1 is 7 initialized to. And then let's see the examples here. Int is equal to 2. 2 is okay, index with value 9. So here math dot max of nums of I, which is 9. 9 plus previous 2, 2. 9 plus 2, 11 or 7. So 9 plus 2, 11 or 7, we'll take 11 now. And previous 2 will become previous 1, which is 7. And previous 1 will become current, which is 11. Now again, index is 3 now. And yeah, index is 3 now. So, and we need to figure out, so what's the value? Current. So current is equal to math dot max of nums of I plus previous 2. Nums of I plus previous 2, that is 7 plus 3 is equal to 10, or the previous one, which is 11. So that will stay with 11 only. And then previous 2 will become previous 1, which is 11. And then previous 1 will be equal to the current one. So that will be 11 as well. So previous 2 and previous 1 both are 11 at both are at 11 now. So we will come to the last index now, and we will add 1. Okay, so current is equal to math dot max of num I plus previous 2. So that is 11 plus 1, 12, or the previous one, which is 11. So we will choose 12, and then current value is 12. Previous 2 will become 11, and previous 1 will become 12. But yeah, and we will come out of the loop and we are returning current, which is 12. That looks right for these examples. Let's run it. It should succeed for the base cases or base examples for sure. Okay, return current. Okay, I have initialized it as current inside that. Current is equal to previous one. Let's take it as previous one. Yeah, that can be any placeholder, I guess. So yeah, case 1 and case 2, these succeeds. Let's submit it and see if we have missed any corner cases or edge cases. Okay, 2112. Let's take this use case. So how to analyze this one? 2112, and the expected output is 4 because 2 is there. Okay, I can rob at this house and then at this and then at this house, but I'm returning it as 3. So how to make sure to get maximum profit now? I'm returning it as 3. I'm losing on this one. So why did I miss that? So I'm starting from my previous 2 became 2, and my previous 1 value became 1. Okay, current is equal to previous 1. It's insignificant anyway, but previous one, which is 1. Okay, let's see. Current is equal to math.max of nums of I plus previous 2. Nums of I plus previous 2. Nums of I is 1. 1 plus previous 2. That is 3, or previous 1, which is 1. So current value will become 3, and then previous 2 will become previous 1. Previous 2 will become previous 1, which is 1, and previous 1 will become current, which is 3. And now okay, previous 2 will become previous 1. That's what I'm doing here. Why should previous 2 become previous 1? What I can do is previous 2 will become math.max of previous 1 comma previous 2. So that's what we are doing for current also. Current is anyway will choose the greater of the previous 1 or previous 2 plus this one. So that is fine. So for the previous 2, I think I can retain the previous 2 value 2 here by choosing the greater of the previous 1 and previous 2 rather than just replacing it. Let's run this one now. Math.max of previous 1 comma previous 2. Yeah, for 1 2 3 1. Now I'm returning it as 4 instead of 3. Let's submit this and see if there are any other cases. No. So this works. Okay, this was the minor error which we didn't figure out, which we did not think that use case. That's bad, but it's a good learning. So these are the errors that others also can make. We check the use cases here. We should be proactively thinking about the test cases. Here in the LeetCode, this usually makes us jump because they have given a couple of test cases already for us. But in the actual interviews, if they just give the problem statement and if they don't give the examples or example inputs, then we should be proactively thinking about all the possible cases. What if the number one house is greater than anything else, and we don't have to consider anything. Like let's say if this has 100 and all this has like 99 or 96 in total, and I just have 3 or 4 in the last house, I should just consider robbing the first house and the last house or anything in between which permits. uh, but since I was losing this value now, previous to like when I move on, I was not computing. So now I did not lose. I took the best value out of the previous one and previous two rather than blindly replacing previous two by previous one. So let's remove these comments which we used for tracing. Awesome. So house robber is done. We are left with only one problem now, which is finding the medium of the data, medium from data stream. Okay, this is marked as hard problem, but I don't think we can compare it with the alien dictionary kind of hard problem. So let's see how to solve this one. Lead code number 295, find median from data stream, and it's a lead code hard problem. The median is the middle value in an ordered integer list. So so I remember solving this problem before, and I remember making a mistake by ignoring this ordered integer list. The median is the middle value in an ordered integer list, not just any integer list, in an ordered integer list. If the size of the list is even, there's no middle value, and the median is the mean of the two middle values. Okay, like if the size of the list is even, let's say, if the size of the this is even sized array, right? So if the size of the stream is even, then it is 2 plus 3 divided by 2. 2 plus 3 divided by 2 will become 2.5. And if the size of the array is odd, then we will get a single median value, which is 3. The median is 3 here. But what is misleading is here, in both the example, the array given is in the sorted order. But that doesn't have to be in the sorted order always. They have never mentioned that the input will be in the sorted order. So the median is in the middle. Median is they have given the definition of the median. Median is the middle value in an ordered integer list. In an ordered integer list. So we need to make sure all the inputs that are coming into the stream are kept in an order, kept in a particular order. Then only we can return the median value with a good performance. Okay, there are three methods that we need to support. Median finder, this is the constructor method for the median finder, and then add we can add numbers to that stream, and then find median. So we can find median at any point of time. Adds the integer num from the data stream to data structure. Returns the median of all the elements so far. Answers within 10 power minus 5 of the actual answers will be accepted. Okay. So what's the basic basic very basic brute force approach that we can think of? We can just have a array list kind of thing, and then keep adding to the array list, and whenever we need to find a median, we can sort the array list and find the summation of the median elements. If it's like respectively, if it's a odd sized array or a even sized array, we can compute the median and return it. Let's see, that is one of the approach, but I don't think that's acceptable, or that's the most optimal approach. So that can be implemented, but other than that, how can we think of it? So now, as I said, there is the add num method, and it keeps adding to our data structure, and it's important for our data structure to stay in the sorted order in order to return the median with a good performance. So how can we do that in the sorted order? So let me think. Let's see. I mean, there are a couple of data structures that comes to mind when we need to retain the sorted order. So one is tree set, and the other one is heap. In the heap, we can keep sorting it, right? Like we can keep sorting like what I mean to say is the array won't be sorted in heap, but we will know the maximum value in a particular thing. Let's say in this one, we don't need the entire array to be sorted, but we just need to know the or the median two elements or median one element in case if it is a odd sized array. So how to do that? So let's go back to our whiteboard with by carrying an example also. So here in this problem, let me take a example or copy an example as well. hate the fact that they have given such easy examples here, which doesn't address any corner cases. Let's go back. Okay, this is what they have given. But let's see if they have added 3, 7, 2, and then 4. Okay, add num, find median. Okay, find median and one more add num here. It will be okay. So let's reduce the size of these and output we don't want as of now. So instead of 3, we added 4 elements now. So 3, 7, 2, 4. Here 3, 7, 2, 4. Finally, if we add 3, 7, 2, 4, the sorted order is 2, 3, 4, 7. Okay, so it should be 3 plus 4, 7. 3.5 should be the solution, right? Let's add few more elements actually to make it real good. Let's add a couple of more add nums here, add nums operations, and couple of more values. Let's add 6. Let's add, let's add 5 here. Okay, was 5 there before? 2, 3, 4, 7 was there. Okay, I just made it as okay. So now 3, 7, 2, 4, and then 6, and then 5 is added. So here the sorted one, 6 and 7 will appear like this. So again, the median value will be 4 plus 5, 9, 9, 9 by 9 by 2 will be 4.5. So that would be the output. But we have, let's call find median at the end once. Oh, there is find median, add num, find median, add num, find median, and then add num, and then there is a find median here. Okay, and then let's add a find median at the end also. Okay, okay. So there are 3 calls for find median, and there are several calls for add num here. So when, like, what should be the output at those points? So when we do median finder, that should return null. That is okay. And when we do add num, that should return null. Add num, return null. And then add num, we added 3 and 7. So 3 plus 7, 10, 10 by 2, 5. So when we do first find median, that should return a 5. And then we did add num once again. We added added a 2, and it should return a median value in the sorted list. So sorted between 2, 3, 7 means 3 will be in the middle. So it should return a 3.0. Here it should return a 5.0 since it's a double. Okay, and then again we did add 3 elements into the list, into the stream. So that should return 3 nulls. Okay, okay, that should return 3 nulls. And then one more find median. Once we with that 3 nulls, we added 4, 6, 5. So now 2, 3, 4, 5, 6, 7. Now these are the elements in the sorted list. So 4 plus 5, 9, 9 by 2, it should return 4.5 as the final median. So how to get to this? So now, so we will store the first half of the list in one heap, and second half in another heap. So if one of the heap is like, okay, first half, let's say we added 3. So this can be a min heap, like first half heap, first half, and then I told second half. Okay, we have two heaps, and how to decide first half should be a min heap or a max heap, and second half should be a min heap or a max heap. So in the first half, if we have all the elements, what do we care about? Like in the first half, we care about the maximum element in the heap, right? We don't care about the minimum elements. Like let's say this is the first half of the elements. So we care about the maximum of this one. We don't care about 2 and 3 and those values. We just care about this value of this 4. So this can be a first half max heap so that we get the maximum value in that first half. And from the second half, wherever we store, so we care about the minimum value in that heap. Just 5 is needed for us. We don't care about what's the maximum value there. So we just need the minimum value. So second half min heap. That's what we care about. So now how do we arrange? Let's say, so as and when a number comes or number is added to the stream, number is added to the stream in this order. So 3 was added. Okay. So I stored it in the first half min heap. I'm still brainstorming. And then a 7 came. So what I'll do is I will add the 7 to the either what I can do. I added the 7 here. So this is a max heap. This will bubble 7 to the top and then 3. And then once I have the maximum value here, I can just add it here. What if I just add it in second half min heap instead of adding it here? What would happen? Then I don't know if this value is greater than this one or anything. I do not have any information. So for easier generic formula, I think I can just add it here, add any value that comes into this first half heap. So that will have the greater value in this one. And then I can check if the length of this one or the size of this first half max heap is greater than this one. If yes, then I'll just pop out that element from here and add it to the second half. So I'll do the same thing here. Let's say 2 came now. So I'll add that to 2. So but 2 will be not be the first element here. 3 will be, this is a max heap. So 3 will be the first element. And then I need to, okay, I checked here. First half max heap is greater than second half min heap. So I'll add it here based on that condition. So I'll add a 3 here. Okay, before doing that, let's see. Before adding 2, we call the find median method. So now we have one element in the first half max heap and one element in the second half min heap. So let's say if the size of both of them are equal, then what we can do is we can get the peak from this one first half max heap and peak from the second half min heap, and then sum it and divide it by 2. So 7 plus 3 10 divided by 2 will return us 5.0. Okay, so that is easy one because we had only one element. Let's keep going. Now again we add num 2. So once we add num 2, as we discussed, we will be adding it to this first half max heap. So that will bubble down 2 to further conditions. 3 will bubble up as the max value since this is max heap. And then since the size of this one is greater than the min heap, I will pop from this one, pop the max element which I popped and then add it to the min heap here. So in this one, this is a min heap. So minimum value be at the top rather than the maximum value. And then I will be adding, okay, then again it's asking for find median. So now in this case, I'll check the size of the both the heaps, size of both the heaps. The size of both the heaps are different. So size of second heap is greater. So I will just return the value of the peak element in the second heap rather than summing it and dividing it by 2. I'll just since I know that the size is different, means the total size will be odd, and I'll just return the peak element in this uh, second half min heap. So that would return it as 3. So that would be the median value here. And then next, let's keep adding further. After adding 2, we have to add 4. So I'll follow the same thing. This is a max heap, so 4 will be at the top, and then I'll check the size of this one with the second half size is same. So I won't do anything. So if I won't do anything, that's not a good thing here. Why? Let's see. So okay, so whatever the pattern we followed is not correct. I realized it now. I mean, I would have done the same thing in the interview as well. So why? So I added the 2, 4 here. I want to maintain all the first half max heap elements in this array and all the second half min heap elements. All the second half element in this heap, basically. All the first half elements in this heap. But here you see 2, 3 should be the first half and 4, 7 should be the second half. But 2, 4 remained here. So if the size is not different, then if I think that, okay, I won't be adding it, that's wrong. I need to add it and I need to pop it out and then add it back again here. So that would return as something like this. Now if the size of this one is more, again I need to pop the min out of this and then add it back here to the max heap. So 3 will be the max there. So now it gives the holistic view 2, 3, 4, 7. And then now 6 arrives. 6 is the next element. So where should I add 6? I should add 6 to the second half min heap. Let's try from this one. Try starting from the second half min heap. So that will be populated here. And then I will take the min heap or the min element from this, and then I'll add it to the next stack. I mean next heap here. So max heap 4, 3, 2, 3, 4, 6, 7, and then 5. 5 I will do the same thing. I will just add it to this one. So it will be 5, 6, 7 at this point, and then I'll have to take it out and add it back here 5. But now the size of this one is more. Again I'll just take this one and added it here. So what difference did it make? I just took 5 out of this and added here and then added it back. Since it is 5, it looked that okay, it didn't make any difference. What if it was 0? So if it was 0 instead of 5, the last value was 0 instead of 5, then let's say 0 I added here, then it would have been since it's a min heap, 0 also would have stayed as the first element here. But after adding into this first half min heap, 0 would have gone down here. And then if I check the size or compare the size and then added it back, then instead of I won't add back 0 here, I would have popped the 4 out of this, which is the max element, and added here. Now the segregation is proper. I just have the first half elements here and the second half elements here. That's why I have to keep exchanging the not exchanging, keep moving the element between those two heaps. So since we decided on going with 5, let's replace it with 5 only. 5, 6, 7, and then 4. Okay. Now in this case, again we are calling find median. Now the size of both the heaps are same after doing those operations. So now I'll just take the peak. Peak is 4 here and peak is 5 here. 4 plus 5, 9 divided by 2 is 4.5. So that would return the output. So let's look into the implementation of the same thing. Let's see here how difficult or easy it will be. Yeah, I thought it's easier, but yeah, it is not too easy to get the mental model. But once we know the solution, it should be fine. So let's say priority queue of integer. Let's name it as first half max heap. Okay, okay, and priority queue min heap, second half min heap. Okay, so this is second half min heap. And let's instantiate both of those. New priority queue. Let's instantiate both of those in the constructor method here. So as I had in Java, priority queue by default will be a min heap. So if I'm instantiating a min heap, I don't have to do anything, and it's a integer. It will like the language knows how to sort an integer, so I don't have to pass anything here. But here, I need to make sure that it's in the reverse order. So collections dot reverse order. I'm passing that one into this into this priority queue so that it should be a max heap instead of a min heap, which is provided by default. Now add num. Coming to the add num. Okay, coming to the add num, like what we saw was like changing hands between the min heap and the max heap, and then making sure they both balance in size also, and then our bigger elements remains in the second half and smaller elements remains in the first half by getting the maximum element in the first half at the top and minimum element in the second half at the top here. So for the easier access, those are needed for median calculation for us. So let's add here. So so whenever a number comes in, what I'm doing is second half. Okay, let's just add it there. Like it will be a set of fixed operations. So second half dot offer num. Okay, and then let's do first half max heap dot offer second half min heap dot pop. Okay, we know that at least second half will have one element, right? Because we just added it here, and then we are popping it out and adding it in the first half max heap. Okay, so we are adding it in the first half max heap. So now if every time we are adding at the end to first half max heap, so if first half, okay, and first half max heap dot size, by adding like that, if that size is greater than second half max heap size, then just pop the top from there and add it to the second half min heap. Okay, so this should rebalance the size. Okay, so once that is done, okay, if size is greater means that means it will have at least one element, so I don't have to do any empty check or anything. So yeah, this is good. And now find median. Let's say if, and it's a double value and we have taken it as integers, and here also num is given in the add num. So have storing them in the heap of type integer is fine because integer values are added. But in the median, we need to return it in the double form. So the first thing is let's check the size of both of those. If first have size, um, let's see, let's check the same thing. If first half dot size is greater than second half min dot size, then we can just return first first half max heap dot peak, and then we need to convert it into a double double format. Yeah, if not, if the first half max heap size is not greater than second half, okay, whenever first half max heap size is greater than second half min heap size, I am adding it to the second half min heap. So there's a chance of second half min heap is of greater size. So let's say, let's make that as in our condition. Okay, if this is greater, I'm adding it here, I'm popping it from the, sorry, I'm returning the minimum of the second half min heap, or else I need to return the double of second half min heap dot peak plus first half max heap dot peak and divide it by 2. Let's see, let's run this one and check if we have missed anything obvious. Okay, in this one, okay, it's poll method, not pop in this, uh, in the priority queues. It's not a stack. Okay, so the base cases you see, it's giving 1, 2, 3. We have added it in the order here, so this is not a good test here. Let's copy from our whiteboard whatever the test case that we had written. I think we should practice more often to write complex test cases by ourselves rather than relying on the test cases being provided. Okay, and then the values also we need to provide. Okay, so I hope this is formatted correct. Let's run this one. Okay, so we can see here, as we had noticed in that whiteboard example, we added 3, 7, and then the median value is 5. And then we added 2, the median value is returned as 3.0. And then we added 4, 6, 5, return null, null, null. And then for the final find median, it is returning 4.5. So that is as expected. So the base cases that we devised the approach and we verified for works for us. Let's submit it and see if this works for other test cases as well. Okay, it works. So yeah, this is a good approach, and this would clarify our understanding in priority queue much more, and how and the usages that we can, or the applications of the priority queue much more. So yeah, like I think this was a good session. We solved few of the difficult problems or the different problems than what we usually do. So should we keep going, or should we leave it to the next session? Is anybody in the stream still? I see there are 4 people. If you reply, I'll keep going more. I might solve a couple of easier examples or easier problems in the from the blind 75 list only, or else I'll end the stream and I'll continue tomorrow. What do you say? Okay, I think it's time now. It's 11:17 p.m. now in the Pacific time, so I'll end the day. I'll end the stream for now, and let's start it again tomorrow with a few more problems. So let's see the status now. So if I okay, we have solved 23 problems out of 75, so we are still far from our goal, far from reaching our goal. I think tomorrow should be a good day. Let's try to get to 35 or 40. That's a tough ask, I know, but let's do that. I think we solved a couple of hard problems, LeetCode hard problems today, alien dictionary and find median from data stream. This one I didn't feel it as hard while solving. It was okay. Alien dictionary was actually a hard problem, but yeah, so that was good. And we learned about coin change and jump game and house robber, which were kind of quite similar, to be honest. But yeah, I think tomorrow we can. I'll come up with an agenda for tomorrow's problems. Let's see what else we can solve. And until then, let's keep improving. Uh, look into the stream, and if you have any questions, please feel free to comment in the same video or write it to me on my email. I'll make sure to address it and respond to you. And if you need any help with making your plans for studying or some preparation, I'll be there. Like, I'll try to help out with that. I have done this multiple times in my career, so um, yeah, I can be of help. So this, yeah, I'm having fun while creating these videos. This is helping me as well. I'll keep up with these kind of sessions. Like now, I'm doing Blind 75. I might start with learning the programming language Golang, or I might do learning about machine learning. But I'll keep doing the live stream while I'm at it. And yeah, let's all learn together. Let's keep going. And until next time, see you.